Hello and welcome. In this example, we want to try to identify the peak-to-peak, RMS, and average values based on this sine wave diagram we have here. And we see that there are voltages given along this edge here that tell us what our scale is for the circuit. And so we don't have any time factors happening, so we don't know anything about our period or our frequency or our cycles. We just know that the cycle ends right here, and that's where it would begin to start over again. So we're not going to worry about that. We're going to worry about our voltage only, the magnitude, which is the rise of our circuit. Right? So for our peak, we'll say Vp equals, and we'll find that. We'll look at our diagram. We see that the peak voltage occurs at the very top of our waveform, the very, very top. We see that that happens at 1 volt. So we'll trace that over and see whatever number is there. That's our peak voltage, 1 volt. Right? Our peak-to-peak voltage is twice that, because our peak-to-peak has to go from the top up here and all the way down to the bottom here. So we trace this over and we act like these two are connected here, and we see what the difference is between here. So this is -1. And we see the top one goes back to +1. And so this is a 1 and a 2. Right? So now we have 2 volt difference for our peak-to-peak. So our V peak-to-peak is equal to 2 volts. Right? We can get that directly from our peak voltage also, because our peak to peak is also equal to our 1 volt multiplied by 2. Our next one is going to be our RMS voltage here. RMS is going to be our average over time, and we actually use our peak voltage to calculate RMS. So we'll say that our VRMS is equal to, and we'll say that that is our 0.707 multiplied by Vp. And we can calculate that out with our calculator here and say that we have 0.707 times the peak voltage, which we know is 1 volt. So we'll get 0.707 volts. So our VRMS is equal to 0.707 volts. Right? And then last one here is our average voltage. And we know that that relates to our 2 over pi equation. So we'll say VAVG is equal to 2 over pi. We know pi is 3.14, and we know that this has to be less than 1. So if you accidentally flip this over, type it into your calculator and see what pops out. Because it's supposed to be a 0.637 decimal range. And so you can easily identify if you've accidentally flipped that over. You can use either one. You can use the decimal or this 2 over pi. We'll multiply this by our Vp, and that's going to give us our average voltage. We'll send this out, and we know that we have 2 over pi, and then we'll multiply that by our peak voltage of 1. So we get a 0.637 volts. Right? We can put both of those into millivolts if we wanted to make them a little bit more accurate, because we can also put our notation into these. But make sure you identify which one's which. Right? So at the end of each one of these, you want to say AVG for the average. You want to say RMS for your RMS voltage value, peak to peak for your peak to peak value, and VP for your peak value. That way, when you look back at them, you'll know exactly which ones are which. All right, let us know if you have any other questions.